Hello, we'll be talking about statistical concepts and market returns. So here there's this measures of central tendency. Measures of central tendency, we'll be talking about the geometric mean. When do we use the geometric mean? How can we compute it? And so on and so on. Let's look at this. Let's look at several years, 2016, 2017, and so on, and let's look at a certain amount of money put on your bank account at the end of those years. For example, if we have $1,000 at the end of year 2016 on this bank account, and at the end of the following year, 2017, we have $1,200 on our bank account, 1,200 the year thereafter, and $1,100 and then $1,300 at the end of the year 2020. So there are certain increases and there's one decrease. From year 2016 to the year 2017, it's an increase of 20%, because 1,200 divided by 1,000 is like an increase of 20%. From the year 17 to the year 18, there's no increase at all, 0%. From the year 2018 to 2019, there's no increase at all. Actually, there's a decrease of, say, 11 divided by 12. There's a decrease of 8%. Actually, it is 8.33333 and so on percent. And then in the last year, from 2019 to 2020, it's 13 divided by 11, so it's an increase of 18 and so on percent. The increase is already noted by the plus sign, whereas a decrease is denoted by the minus sign, of course. Now, if we compute, we want to know, so what's the average increase or what's the average decrease of the money on this bank account? And if we did it the following way, we'd be dead wrong with it. If we compute the arithmetic mean of those increased numbers, it would be totally wrong. Why? We'll show in this video. The geometric mean deals with an average value, with a mean of increases or of decreases. So deals with the mean of percentage points. And the following holds true. If we have an increase of 20%, we have x1 of 1.2. x1, the increasing factor, to put it this way, is 1.2. The second is 1.0, because there is no increase at all. The third, x sub 3, is equal to 1 minus is equal to 0.916 and so on and so on. 667 if we want to round it to this to the fifth decimal place. And x sub 4 is equal to 1.18 and so on. Now there's a big difference between the increased numbers and those those values. If we have a 1 at the beginning, it's an increase. But if the number commences with a 0, it's a decrease. That's important to know, that's important to understand. Now, the geometric mean is computed the following way. The nth root of the product of those numbers. So, it's 4 numbers. It has been 5 years, but it's 4 numbers, because if it is 5 years, the end of 5 different years we look at, we have 4 different numbers when it comes to how the money increases or how the amount of money decreases. So it's the 4th root of 1.2 times 1.0 times 0.9166 times 1.1818 and so on. That's the fourth root. So this is, we want to compute this now. Let's try together. It is the fourth root of 1.3 which is 1.3 to the power of 1/4 to the power of 0.25. So we get 1.3 to the power of 0.25, which means it is 1.067779 if we want to round it to the fifth decimal places. Which means that the average value, that the average increase of the amount of money on our bank account is given by 6.779%. That's the average value. Is this true or not? It is true, because let's look at this. We have $1,000 at the very beginning. We get 1.06779 to the power of 4, because it is increased or decreased 4 times from the year 2016 to the year 2020. It is increased, decreased 4 times in a row. So, and this 1.06779 to the power of 4 multiplied by 1,000 gives us the end value of $1,300, which is true. So, if you computed it any different way, you'd be dead wrong. If you did it like the arithmetic mean of 20%, of -8%, and of 18.18%. So if you summed it up and divided it by the number of 4, because you have 4 different values, it would be totally wrong. So if you have increases or decreases and you want to compute an average value, it is always true to compute the geometric mean. The geometric mean holds true for increases, for percentage points. That's it for now. Thanks for watching. Thanks for listening to this video dealing with the geometric mean.